screen is visible to everyone?
Yes, ma'am.
Okay. So this is your homework, right? So this was your homework, and I don't know who have done it not except Ishita. I didn't get any response. Aditya, have you done beta?
No, ma'am.
Why not?
मैम मैं कल घर पे नहीं था मैम, फंक्शन था, मैं वहाँ पे था.
Abhi, I have discussed both questions, right?
Yes,
You
ma'am.
will do it. Okay,
Okay, sir.
everyone try. Okay, so today we will be covering double integral in polar coordinates. Polar coordinates, when we are talking about x and y, those are your Cartesian coordinates. X and y, these are Cartesian coordinates. When you are converting these Cartesian coordinates into polar coordinates, so you use x is equal to r cos theta and y is equal to r sin theta. Earlier, I think I have discussed how we are writing x is equal to r cos theta and y is equal to r sin theta. So let us have this point, that is your x comma y, any point, right? What is this r? R is the distance of this point from this origin. So I'm joining it, and this is your r. R is a radius vector, that is the distance of a point from the origin. And this angle theta. What is this theta? Theta is the angle made by this radius vector along with this initial line. When you're talking about r and theta, so this x-axis is known as initial line. So many time it will be written in the question above initial line, along initial line. Initial line means it is your x-axis. So now from this point I am drawing a perpendicular on initial line, right? So this is what it is, your x coordinate, and this is your y coordinate, right? So we can write x upon r base upon hypotenuse. X upon r is equal to cos theta. So from here we write x is equal to r cos theta, and similarly perpendicular upon hypotenuse is equal to sine theta. So from here we'll be writing y is equal to r sine theta. So this is we use while converting Cartesian coordinates into polar coordinates, right? When you are squaring and adding it, so you'll be getting one relation, r is equal to under root x square plus y square. Or if I'm squaring and adding, x square plus y square is equal to r square. So it simply represents a circle with center at origin and with radius r. If you divide it, then tan theta is equal to y by x, and theta can be written as tan inverse y by x, right? So r and theta are your polar coordinates. Now, evaluation of double integrals in polar coordinates when limits are given. In case of Cartesian, we discussed like evaluation of double integral directly when limits are given. Secondly, evaluation of double integral when region is given. Similarly, we will be discussing in case of polar coordinates. So first is evaluation of double integral in polar coordinates when limits are given. So evaluate 0 to pi and 0 to a 1 minus cos theta r sine theta dr d theta. So what you will be getting from here, double integration f of r comma theta dr d theta, right? In Cartesian form, double integration f of x comma y dy dx was there, right? In polar form, xy will be converted into r and theta. So it would become double integration f of r comma theta dr d theta. And then you'll be having limit of r that would be in terms of theta. right? And limit of theta would be in terms of theta only. That means constant. In this case, this variable, this limit would be in terms of theta, and limit of theta would be constant. So let us represent it with alpha and beta. Don't say theta 1, theta 2. So it may be confusion. So limit of r would be function of theta to another function of theta, and limit of theta would be constant. Let us say that is alpha to beta or a to b. Ultimately, this limit would be constant and this limit would be in variable. So this is your function f of r comma theta, r sine theta, dr d theta. Limits of r 0 to a into 1 minus cos theta. That is in terms of theta, and limit of theta is constant, right? So how you will evaluate? You will evaluate. See, this is in terms of theta na. So if I will integrate it with respect to r, keeping theta constant, and then I'll be putting this limit in r. So ultimately, this integral, after solving this integral, you will be getting everything in terms of theta, and then you need to integrate with respect to theta, right? So first we will be integrating it with respect to r, keeping theta constant. So let us do it. So we are writing the sine theta is constant. So keeping outside, integral 0 to r, a into 1 minus cos theta, r dr d theta, right? So you'll be integrating it with respect to r. So it would become r square by 2. So r square by 2. Then upper limit minus lower limit. So you'll be putting here a square by 2 constant, keep it outside, 0 to pi. When you are putting here 1 minus cos theta, it become 1 minus cos theta square into sine theta d theta. Now simplify it and let me know what will be the answer. How can we solve it? Okay, I'll giving you hint. Put 1 minus cos theta as a t. Put 1 minus cos theta is equal to t. Then differentiate on both sides. You'll be getting differentiation of 1 is 0 minus cos ka differential minus of sine theta into d theta is equal to dt. Right? So sine theta d theta is equal to dt. Now check the limit. If theta is pi, if theta is equal to pi, then t is equal to what? Tell me beta, what will be the t? If theta is pi, then what will be the t? Yes,
Ma'am,
beta, tell me what will be t?
2.
T would be 2. 1, yes, beta, right? 1 minus cos pi. Cos pi is minus 1 minus minus plus. So t would be 2. And if theta is equal to 0, then t would be 1 minus cos 0. Cos 0 is 1. 1 minus 1 is 0. So now new integral would be a square by 2 integration 0 to 2 1 minus cos theta square means t square. Sine theta d theta would be replaced by dt. Now simplify it and let me know what will be the answer. Integrate it and let me know what will be the answer. T square by 2 into, yes, integrate t square beta.
Ma'am, 4. Ma'am, yes, ma'am, 4.
Answer is sure. It would be t cube by 3. Integrate किया आपने and then you are putting the limit 2. So I'm putting at the place of t, I'm putting 2. It would become 2 cube. So it will be cancel out. So I think you'll be getting answer is 4a square by 3. Getting or not?
Yes, ma'am.
Only one student is getting 4a square by 3. What about others, beta? Yes,
I'm
Prabal?
saying 4a square by 3.
Okay, beta. Thank you. Anyone else who is getting the same answer? See beta, if you don't respond then there will be no benefit of teaching like this. तो ठीक है, इससे अच्छा तो मैं सिंपल पढ़ा देती हूँ, बैठती हूँ, सब स्लाइड्स दिखा देती हूँ आपको. It's very simple integration beta. You have to integrate and if you will not respond तो बिल्कुल मज़ा नहीं आएगा पढ़ाने में. So let us check the answer. So answer is 4a square by 3. Now come to the standard graphs with polar equation. Polar equation means if equation would be in terms of r and theta. So you need to remember such some standard graphs or curves. So first is circle with radius 2. R is equal to 2. If we are writing simply r is equal to 2, r is equal to 2. So you know what is r? We have discussed here r is what? Under root x square plus y square. That is equal to 2. Right? So ultimately we'll be writing here x square plus y square is equal to 2 square. Right? So whenever it is written like r is equal to 2, so it means it is a circle with radius 2. Right? And what type of circle? Circle with center at origin and radius 2. Right? And if your circle only this part of circle, so you need what? You need radius as well as theta. See, this is the line of theta is equal to 0. And this is the line of theta is equal to pi by 2. And this is the line of theta is equal to pi. And this line you can write it here minus pi by 2 or 3 pi by 2. Right? So you need to remember these lines. This is theta is equal to 0. This is theta is equal to pi by 2. This is theta is equal to pi. And this is theta is equal to minus pi by 2 or 3 pi by 2. Right? Similarly, if I am drawing a line here in between, so it would be theta is equal to pi by 4. Right? 0, pi by 4, pi by 2. And if I am drawing a line in between of here, pi by 4, pi by 2, so it would be 3 pi by 4. Right? And when I am drawing the same line in these quadrant, so you will be taking this is positive pi by 4, so you will be considering it negative pi by 4. Right? And similarly, if it is 3 pi by 4, so I'm drawing this line, I'm taking it minus 3 pi by 4. Right? Or you can say it, this is 0, 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, and this would be 5 pi by 4, 6 pi by 4 or 7 pi by 4, right? So in our calculation we will be taking like that. अगर आपको कोई रीजन है जो यहाँ से लेकर यहाँ तक लाई कर रहा है, so your limit would be minus pi by 4 to plus pi by 4. अभी at present you are having this curve only, right? So for this angle would be what? For this angle would be 0 to pi by 2. This is theta is equal to 0 and this is theta is equal to pi by 2. So if question is like evaluate double integration r dr d theta over first quadrant of circle, that is r is equal to 2, right? Evaluate this integral over first quadrant of circle r is equal to 2. So this is what? You know it is a circle with center at origin. First quadrant bola hai, so we'll be taking only this part of circle, right? So what you do generally, I'll discuss it later on also, you make a strip here. We make here radial strip. So in radial strip, you'll be starting from origin. So this complete region is the region of integration. So r is 0 at this point and r is equal to 2 at this point. So you will be having the limit of r is 0 to 2. And then to cover this whole region, we will be sliding this strip like this in this rotation. We will be starting from here and this is the line, theta is equal to 0. So limit would be 0. And you will be moving from here to till this line, and this is the line, theta is equal to pi by 2. So limit would be pi by 2, right? If you're taking circle above the initial line, this is your initial line, x6 is the initial line, above the initial line, then limit would be what? 0 to, what will be the limit for this circle with a semicircle? This is what? This line represent what? Theta is equal to, what is it beta?
0 degree.
0 degrees. So theta is equal to 0. And we know that this is the total region, both quadrant. For such type of curve, theta will vary from 0 to, we'll be starting our strip from here and we will slide it up to here. So what is this line? This line is, what is the angle at this point?
Pi.
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 So yes, beta. Thank you, Bachchan. Theta is equal to pi. So if your region of integration is such type of circle, means circle, semicircle above the initial line. So you will be making a strip here, right? So radius तो would be 2 ही ना, because आपके पास radius का है r is equal to 2. So 0 से लेकर 2 तक आपका radius हो गया और इस strip को हम move करेंगे कहाँ से? यहाँ से लेकर यहाँ तक, तो सारा एरिया कवर हो जाएगा. So in this case, limit of theta would be 0 to pi. In this first quadrant, limit of theta is 0 to 90 degree, that is pi by 2, right? Similarly, if it comes like this, तो आप उसे शुरू करते हो 0 से लेकर 3 pi by 2 तक, right? And for this complete circle, 0 to 2 pi. 0 to 90, 180, 270 and 360. So if you are considering this whole circle, then theta limit would be 0 to 2 pi. Now come to the next. This is the circle, r is equal to 2 cos theta. And this is r is equal to minus of 2 cos theta. First you have done r is equal to 2. You need to remember all these things, beta. If r is equal to 2, it means circle with center at origin with radius 2. This is the circle, right? Now I'm saying circle r is equal to 2 cos theta. How it is circle? You can check it, convert it as into Cartesian form, then you can check it, right? So how this circle is made, what to do, you need to just put the value of theta over here. If I'm saying theta is equal to 0, these all are the part of curve tracing beta, right? In this, we trace the curve. And how we trace the curve in polar coordinates, we just put the angle theta. You know the every line of this line represent theta is equal to 0. Theta is equal to pi by 4 means 45. If I'm drawing here, theta is 30, 45, then 60, then 90, right? Then 120, then 150, 180, and so on. So if you want to draw any curve, you need to just put the value of theta, and whatever value you are getting now, just represent that number on that line. See, if I'm putting theta is equal to 0 in this. So cos 0 is 1. So if I'm writing theta is equal to 0. तो what is the r? Radius vector क्या होगा आपका? Theta 0, 1. So radius vector would be 2. Right? So आपकी line क्या है? Theta is equal to 0. This is the theta is equal to 0 line. And r is 2. So you are mentioning point at here, this 2. Done? And then let us see, this is the line theta is equal to pi by 4. Right? So if I'm putting theta is equal to pi by 4, theta is equal to pi by 4, then what will be the value here? 2 into 1 by root 2. Right now? Cos 45 is 1 by root 2. So you will be simplified. So you'll be getting value less than 2, 1 point something when you'll be solving it. So this line theta is equal to pi by 4. Whatever point you're getting, you will be displaying it here. Is it right, beta? Similarly, when you'll be putting cos 90 would become 0. So r would become 0. So this is your line 90 and this will be your point. So then for drawing the circle, you will be joining this in this form. Right? And this cos theta is a even function. Right? So when you'll be replacing theta with minus theta, so you will be getting your same values. So you can draw it in the similar way. Now, no one will ask you how to draw this circle, right? I'm just telling for your understanding, if you need to draw any curve, so you can just put the values of theta and draw the circle. Keep one thing in your mind, whenever you are getting here negative value, let's say somehow you are getting here minus 2. So whenever you are getting negative value now, so you need to represent that point on opposite side. Like in this circle, r is equal to minus 2 cos theta. When you are putting theta is equal to 0, then r is equal to minus 2. Right? So instead of marking this r is equal to on theta is equal to 0 line, we will be representing it in opposite line. So theta is equal to 0. इसका opposite line क्या है? Theta is equal to pi. Just opposite. This 0, so this pi. So r is equal to minus 2. This would be your point 2. If you want to check any drawing of any curve, I'll just tell you the shape. Okay? I cannot discuss each and every shape, but for your understanding, how we draw, we just put the values of theta. You know the lines of theta, right? And if corresponding to any theta, you are getting negative value, then you need to show that point in at the opposite side, right? So you just keep this mind, r is equal to 2 cos theta. This is a circle and it would be on the positive side of x-axis, right? If you are having a circle minus 2 cos theta, so it is a circle on the negative side of x-axis. You will remember it like that, right? And similarly, r is equal to sine theta. See, in this, we have mentioned each and every line. And whenever you'll be putting here theta, you will be getting value corresponding, you can draw it. See, when I'm putting theta is equal to 0, r is 0. So on this line, this point is 0, right? And then theta is equal to pi by 2, so it would be 1. So it is point is 1, right? And at this point, it is what? Sine pi by 4. Whatever value you'll be getting, you will displaying here. Similarly at 3 pi by 4, and then sine pi, you know it is a 0. So this is your sine circle. Cos circle would be on x-axis, sine circle would be on y-axis, because we know that sine 90 is 1 and cos 90 is 0. Is it clear? Yes or no?
Yes, ma'am.
Now tell me, if I'm asking you r is equal to minus sine theta, तो वो circle कहाँ बनेगा? See, cos theta was on positive, cos theta was on positive x-axis. Negative cos theta would be on negative x-axis. Sine theta is on positive y-axis. So I'm asking about r is equal to minus sine theta. तो कौन से एक्सिस पे बनेगा?
Negative by axis.
Negative y-axis पे. So very nice. R is equal to minus of sine theta. Is it clear? Keep in mind, if r is equal to a, it means that is a circle with center at origin, right? If r is equal to a sine theta, that will be on positive y-axis. R is equal to minus a sine theta, that will be on negative y-axis. R is equal to a cos theta, that would be on positive x-axis. R is equal to minus a cos theta, that would be on negative side of x-axis, right? Now, after that, you have done 5 circles. Now, next is cardioids. Cardioid means that is related to cardiology, right? Heart. So, all pictures will be in shape of heart. Again, you will remember, like, if it is r is equal to 1 plus cos theta, so this cardioid will be on x-axis, because cos theta है, theta 0 पे भी value lie करेगी, theta pi पे भी value lie करती है, right? So r is equal to 1 plus cos theta would be on x-axis, and r is equal to 1 plus sine theta would be on y-axis. You have 4 cardioid beta. R is equal to 1 plus sine theta, r is equal to 1 minus sine theta, r is equal to 1 plus cos theta, r is equal to 1 minus cos theta, right? These are 4 types of cardioids. You need to remember these shape. Why? Because in question it will be asked, find the area lying between the circle and cardioid, or find the area lying outside the circle inside the cardioid. When we are saying about cardioid, right? So it should be in your mind ki what is the equation for cardioid, right? It can be asked what will be the equation of this curve. तो आपको कर्व को देख के पता लगना चाहिए कि कौन सा कार्डियोइड है, right? Now, how to remember it? One cardioid is like this. This is 1 plus sine theta. And if you are drawing 1 minus sine theta, so it would be like this, right? How you will remember? If it is plus sine, then maximum part of cardioid would be on positive y-axis. Can you observe? This is your cardioid, and maximum part of cardioid would be on positive y-axis, right? And r is equal to 1 minus sine theta. I'll be drawing like that. Maximum part of cardioid is on negative y-axis, right? So this is cardioid, r is equal to 1 minus sine theta, and this is the cardioid is 1 plus sine theta. Sine है, you always relate sine with y-axis, because sine 90, theta 90 y-axis पर है, और sine 90 हमेशा वो 1 होता है आपके पास, right? In case of cardioid, cos cardioid, r is equal to 1 plus cos theta. So when you are saying the plus sign, so maximum part would be on positive x-axis, positive x-axis. If I'm saying 1 minus cos theta, so it would be on the other side, right? This is on other side. And maximum part of cardioid on negative x-axis. This is how you can remember it, right? 4 cardioid, 1 plus cos theta, 1 minus cos theta, 1 plus sine theta, 1 minus sine theta. If it is plus sine theta, so maximum part would be on y-axis. If it is minus, maximum part would be on negative y-axis. If it is cos plus, maximum part of cardioid would be on positive x-axis, and minus cos theta means maximum part of cardioid would be on the negative side of x-axis. Is it clear? याद रहेगा? Yes or no?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. You have done 4 circles and 5 circles and 4 cardioids. Now come to the next. This is lemniscate. Lemniscate is in this form, like this. Okay, you need to remember this shape. You need to draw 8 on x-axis. Equation is r square is equal to a square cos of 2 theta in polar coordinates, and this is the equation in Cartesian coordinates, right? And if we are talking about the polar coordinates, this line is theta is equal to pi by 4, and this line is equal to theta is minus pi by 4. And if your region of integration is this, right? So you'll be making a strip in this area, right? Here r is equal to 0, and this curve is defined by what? Equation this. R square is equal to a square cos 2 theta. So from here we'll be getting r, that is a under root cos 2 theta. And then sliding for this whole one loop. For this one loop, you'll be sliding your strip from minus pi by 4 to plus pi by 4, right? There are 2 types of lemniscate, one with the cos, another with the sine. Right? Similarly, if you will be putting theta is equal to 0, so r is equal to a, r square is equal to a square. So you'll be getting 2 point, r plus minus a. For plus, I'm showing point here, and for minus, I'm showing point here. Right? Similarly, you'll be putting here pi by 4. When you are putting here pi by 4, so it would become what? Cos 90, and cos 90 become 0. So at pi by 4, this value from a, it would be decreasing, and at the line of pi by 4, it would become 0. Right? Similarly, you can make this and this and this. Just put the theta and get the value of r and display that. So you will be, this type of 8 become in the a square cos 2 theta, and for sine theta, this would be for sine theta. Theta is equal to 0, तो यहाँ ही point 0 ही रहेगा. When you are putting here theta is equal to pi by 4, so it become what? 2 into pi by 4, sine 90, that is equal to 1, so r is equal to a, so value would increase from 0 to a. Right? And then it come from a to 0. Right? So you need to remember this line is what? Theta is equal to pi by 4. So this lemniscate is symmetrical about the line theta is equal to pi by 4, and this is the symmetrical about the line theta is equal to 0. Right? Cos है इसीलिए x एक्सिस पर बनेगा. Sin था probably इसको y एक्सिस पे बनाना पड़ता है, but due to this 2 theta, it would not be on the exactly y axis, it would be shifting on this line theta is equal to pi by 4. Right? So you need to remember this. This is the lemniscate, a square sine 2 theta, and this is the a square cos 2 theta. 5 circles, 4 cardioids, 2 lemniscate, right? And then This is the curve known as folium of Descartes. And this is the Cartesian equation, x cube plus y cube is equal to 3axy. In this, you'll be putting a point x when x is 0, y is 0, x1, y corresponding what you are getting, and corresponding you will be drawing it. Right. One more thing, while tracing these curves, we see the symmetry. Right. The curve is symmetrical about x-axis, symmetrical about y-axis, symmetrical about theta is equal to pi by 2, and so on. Right? So whenever you are getting even function is symmetrical about x-axis, and odd function is symmetrical about origin, or symmetrical in opposite quadrant. Right? If you're talking about this cos is even function. So even function is symmetrical about x-axis. X-axis symmetrical means whatever you're getting above the x-axis, same you'll be getting below the x-axis. This is symmetrical about x-axis, right? And see, this is the cos. Whatever you are getting above x-axis, same you're getting below the x-axis. Or if you are folding it from this axis, so they will be overlapping each other, right? So cos is symmetrical about x-axis, right? And sine is symmetrical about opposite quadrant, or that is symmetrical about origin. So this is again cos function, cos theta, symmetrical about x-axis. This is symmetrical in opposite quadrant, right? So you need to keep this in your mind. Okay. After that, after this folium of Descartes, 3-leaved rows. R is equal to sine 3 theta. So this is the shape for R is equal to sine 3 theta. Again, you can make it like put the value of theta, whatever value you are getting, you can display it on that line. This is R is equal to sine 3 theta. If n is odd, then you will be getting odd number of leaves, right? 1, 2, 3. This is 4-leaved rows. Equation is R is equal to cos 2 theta. If this is even number, then you will be having 2n leaves, right? This is 2, then in your curve you'll be getting 4 leaves. This is known, this is 1 leaf, 2nd leaf, 3rd leaf, and 4th leaf, right? So there will be, if n is even, then there would be 2n leaves. If n is odd, so there would be n leaves, right? So here n is what? Even, so we'll be having 2 into 2, 4 leaves. So 1, 2, 3, 4 leaves, right? And this was, n was odd, so we'll be having n leaves, 3 leaves, so 1, 2, 3 leaves. Similarly, this is 4-leaved rows. Again, R is equal to sine 2 theta. It is even, so again you'll be getting here 4 leaves. Now see the difference. These leaves are on these x-axis and these y-axis, and these are would be on this pi by 4, 3 pi by 4, 5 by 4, and 7 pi by 4. Why? You know well, because of this theta and 2. When you'll be putting here pi by 4, so it means you will be getting R is equal to 1 at line pi by 4. So it will start from like this, right? And this is because cos theta 0, R would be 1. So that is why this leaf is on this line, right? So you need to remember all these shapes as well as equation. If I'm asking you find the area of one loop or leaf, this is also known as loop or leaf, area of one loop of this curve. तो आपको क्या बताना चाहिए? R is equal to cos 2 theta. How to sketch it? We are sketching like this. And then if I'm asking about the area, so you can find the area of this half leaf and then you can take it twice of that area. So that will be the area of one loop, right? R is equal to sine 3 theta, this is 3 leaf rows. R is equal to cos 2 theta, R is equal to sine 2 theta, both will be 4 leaf rows, right? And this is known as cissoid of Diaculus or Limacan cissoid. You need to remember this curve. This is your equation in Cartesian coordinate, it is in polar coordinates, and this is the shape. So you have done all the shapes, just revise it. Mainly you will be using all these. R is equal to 2 means this is a circle with center at origin and radius is 2. Then R is equal to 2 cos theta. Cos theta circle would be on positive x-axis. Minus 2 cos theta circle would be on negative x-axis. R is equal to sine theta circle would be on y-axis. Minus sine theta circle would be on negative y-axis. Cardioid. For cardioid, R is equal to 1 plus sine theta, 1 minus sine theta, 1 plus cos theta, 1 minus cos theta. So sine cardioid would be on y-axis, cos cardioid would be on x-axis. If it is plus sine, so maximum part of this cardioid would be on the positive y-axis. If it is negative sine, so maximum part would be on negative axis. It is positive, then maximum part would be on positive x-axis. It is negative, then maximum part would be on the negative side of x-axis. Then there will be two lemniscate, one on x-axis and one on theta is equal to pi by 4. And then this is volume of Descartes. This is 3 leaf rows. R is equal to sine 3 theta. If R is equal to sine n theta, standard equation if I'm writing, R is equal to sine n theta. If this n is odd, so n leaves would be there. If n is even, then there would be 2 n leaves in that sketch, right? If R is equal to sine 3 theta, so there would be 3 leaves. If R is equal to cos 2 theta, there would be 4 leaves because n is even. Similarly, R is equal to sine 2 theta, it would be again 4 leaves. So you need to remember in cos 2 theta, leaf would be on x-axis and y-axis. One positive x-axis, negative x-axis, positive y-axis, negative y-axis. In case of sine 2 theta, that would be on pi by 4, 3 pi by 5 by 4 and 7 pi by 4. 4 leaves. This is how you can remember it. Now, come to this. Evaluation of double integration in polar form when region is given. So first of all, we'll discuss how to write the limit. R is equal to, this is the region in the polar coordinates. R is lying between R1 theta to R2 theta and theta is lying between alpha to beta. So this is any curve, R is equal to R2 theta, and this is another curve, R is equal to R1 theta. This is the line of theta is equal to alpha and this is the line of theta is equal to beta. So O, A, B, C. This is the region of integration bounded by these two curves and these two lines. This one only. This is the region of integration which I'm highlighting here. Right? So what you will do now? In Cartesian, we'll be taking vertical strip or horizontal strip. In this, we will be taking radial strip. So that radial strip taking from the origin. So we are starting from here and making a strip over here. But we will be considering the strip which is lying in our region of integration. So this is your initial limit and this would be your final limit. So initial limit, what is the equation of this curve? That is R1 theta. So it would be your lower limit and this would be your upper limit. Curve for equation for this curve R is equal to R2 theta. So you will be writing here R1 theta and R2 theta. Now you need to slide this strip. So you will be sliding it. You will be sliding it from here to here. When you will be sliding from here to here, then whole region would be covered, right? So theta is starting from here and going up to here. So this is the line for theta is equal to alpha. So we'll be putting here alpha. And this is the line for theta is equal to beta. So we'll be putting here beta. So this is how you write the limits for polar coordinates. Right? Now, let us have one example. Calculate double integration r cube dr d theta over the area included between the circles r is equal to 2 sine theta and r is equal to 4 sine theta. Right? Now my first question is how to sketch r is equal to 2 sine theta. R is equal to 2 sine theta. How we will sketch it? Now you will tell me
Ma'am,
beta then. Yes, beta Harinder.
ma'am, positive y-axis
Positive
on.
axis पे. So r is equal to 2 sine theta. Now keep this in mind that this is your radius vector. R is equal to 2. We know that this is the positive sine theta, so it would be on the positive y-axis. So I am drawing this circle, this, like this. And this is your point 2. Radius vector is what? Distance of this point from this origin. This is the circle r is equal to 2 sine theta. Next circle is r is equal to 4 sine theta. So it would be on positive y-axis, but now this time radius vector would be 4. Distance of this point from the origin is 4. So I am drawing this circle like this. Sorry, it would be on like this. Is it clear, beta? Is it right? How to draw the two circle? R is equal to 2 sine theta and R is equal to 4 sine theta. Now, area between the circles. तो ये हमारा circle होगा. This is the region of integration. Right, beta? So, you will be writing like this, double integration r cube dr d theta. So I need limit of what? R, and then I need the limit of theta. Now I'm making a radial strip from this center. This is your radial strip. But I will consider my strip from here. I'm just highlighting this strip. Okay. This is the circle. R is equal to 2 sine theta. And this is the circle. R is equal to 4 sine theta. We need limit of r in terms of theta and limit of theta as a constant. So now you tell me what will be the limit of r? Yes, beta. What will be the limit of r? Region is in front of you, strip is in front of you. From where strip is starting in your region of integration and where it is ending, you need to observe that and tell me.
Ma'am, 2 sin theta से 4 sin theta.
2
Yes,
sine
ma'am.
theta से 4 sine theta. Very good, beta. See, this is the region of integration starting now. So this curve is what? R is equal to 2 sine theta. So this will be your lower limit, 2 sine of theta, right? And strip is going up to this. So R is equal to 4 sine theta. Very good, beta. This is the limit of R. Now tell me the limit of theta. See, ये स्ट्रिप उठाएंगे हम और जहां से आपका एरिया शुरू होता है, जहां से. So we will be sliding this strip from here to here. So tell me what will be the limit of theta? We will be sliding this strip from here
0
to
to pi.
0 to pi. Good, beta. So 0 to pi would be limit of theta. ठीक है ना? This is theta is equal to 0, this is pi by 2 and this is pi. So you will be sliding your strip from here to here. So this variation is theta is varying from 0 to pi. So I'm writing here 0 to pi. Now you need to solve it. So this was the region, beta. This circle is r is equal to 2 sine theta. This bigger circle r is equal to 4 sine theta. This line is theta is equal to 0. This line is theta is equal to pi by 2. And you are drawing a radial strip. Strip is starting from here and ending at here. Right? You need to find out area included between the circle. So you'll be starting from here 2 or 4. ठीक है, this is initial limit, final limit, and theta variation is 0 to pi. So this is your integral. Now integrate with respect to r, keeping theta constant. Theta है ही नहीं, तो you'll be integrating r cube, it become r4 by 4, 4 sine theta, 2 sine theta. Simplify it, you'll be getting 60 0 to pi sine 4 theta d theta. After that, I'm writing here twice 0 to pi by 2 sine 4 theta d theta. Can anyone tell me how can I write this? How can I write this, beta? Any idea? See what I did? I'm taking twice of this integral and I'm breaking this limit 0 to pi को मैंने 0 से pi by 2 कर दिया. Go through your 12th rules. That would be like this: 0 to a f of x dx. That is equal to twice of integral 0 to a fx dx. If f of 2a minus x is equal to fx. Remember? Now 0 to pi. So at the place of 2a, you will be having here pi. 0 to pi fx dx. So you need to check. This is your sine function. Sine pi minus theta is sine theta. So sine pi minus theta is sine theta. This condition is satisfied. So that is why I am taking twice of this. 0 to a means half of this. So you'll be writing here pi by 2. 0 to pi by 2 sine for theta d theta. Now if you are having the limit as 0 to pi by 2 and this is n greater than 1, then you can apply here what?
Reduction formula.
Reduction formula. So you'll be writing here 120. Why I'm applying this property? Just to make this limit 0 to pi by 2 so that I can apply the reduction formula. So 120 into, you'll be starting 4 minus 1, 3 into 1 divided by 4 into 2 into pi by 2. Pi by 2 because n is even, right? So now you will simplify it and answer is 22.5 pi. Right? Any doubt? Till here, any doubt, then please ask. Okay. Now come to this. Evaluate double integration r sine theta dr d theta over the cardioid r is equal to a into 1 minus cos theta above the initial line. Tell me what type of cardioid it is. कैसा कार्डियोइड है? कॉस है, साइन है, कैसे लर्न कराया मैंने?
मैम ऑन मैम नेगेटिव एक्स एक्सिस.
Maximum part would be on negative x-axis. So you will be drawing it like this. Because cardioid hai, it will be in the shape of heart. So we have made it. Right? Cardioid above the initial line means, what is the meaning of this beta? Above the initial line. What is initial line?
Ma'am, ma'am, second quadrant, ma'am, above x-axis region.
Above x-axis. Initial line means above, initial line above x-axis. So I'm taking eraser and I'm only deleting half of its this, so it become like this. That's all only. Right? This is your region of integration. Now you need to find out the limit of R. This is the region of integration. So I'll be making a radial strip from origin. This is the radial strip. Now tell me what will be the limit of R. So this curve is defined by R is equal to A into 1 minus cos theta. Now tell me beta, what can be the limit of R and what can be the limit of theta? Double integration R sine theta dr d theta. Region of integration is in front of you, right? अच्छा छोटा तो नहीं लग रहा? Okay, I'll make it again. Like this, right? And I'm making a strip like this. Now you tell me what is the limit of R. At this point R is what beta? At this point. This is the origin, no? At this point R is what?
Ma'am, 0.
0. At origin R is 0. R is the distance of any point from the origin. तो अभी वो point origin पर ही है, तो distance हमारा 0 है. And what is the upper limit then? Upper limit is defined by this curve. And this is what? R is equal to A into 1 minus cos theta. Is it right? So limit of R would be 0 to 1 minus cos theta. Is it clear? Is it clear, beta?
Yes, ma'am.
Now tell me the limit of theta. We need to slide this strip from here to here to cover the region of integration. From here to here. We will be sliding this strip from here to here. So what will be the limit of theta?
0 to pi.
Yes, limit is 0 to pi. Simple. Like the Cartesian coordinates, similarly you need to follow the strip and rotation of strip. In that, you're talking about the vertical and horizontal. If you're making a horizontal strip, you are sliding it vertically. When you are sliding it vertically, so you need to get the limit of y. Here you need to make a radial strip. And radial is what? Radial is distance of that point from origin. So always it would be strip starting from the origin, right? And while writing the limit, you need to check what is your region. Okay? And according to region, you'll be writing your lower limit and upper limit. After that, you need to take the rotation. For rotation, you need to check theta is varying from where to where. So in this, you know that this curve is starting from here. And theta is equal to 0 is having involvement. So theta से 0 से लेकर pi तक, you will be sliding this strip from here to cover this region. So limit of theta would be 0 to pi and limit of r would be 0 to 1 minus a into 1 minus cos theta. Right? And then you will be integrating it. So I'll show you the solution. This is your cardioid. Because we need to consider above the x-axis, so we are considering only this strip. This area would not be the region of integration. This is not the part of integration. Only this is the region of integration. Strip is starting from 0, going up to a into 1 minus cos theta, and sliding is from theta 0 to pi. right? And this is the similar to first question. You know how to solve it. So I'm giving the solution, you can read it out from here. Now come to the next, change of variable, Cartesian to polar coordinates. Integral would be given in Cartesian coordinates and you need to convert that into the polar coordinates. Why do convert in polar coordinates? It makes your calculation easy, right? So, so therefore we use change of variable, we change the Cartesian coordinate into polar coordinates to evaluate the integral. Because this conversion makes your calculation easy. So how you will convert it? Z is a function of xy, so you will be converting it into r and theta. How you will be converting? You know that x is equal to r cos theta and y is equal to r sine theta. Right? So I have told you one thing. When we were doing the Jacobian, I have told you what is the application of Jacobian. And I've told you you will be learning the application of Jacobian in multiple integrals. In multiple integrals, whenever you are changing the coordinates, Cartesian to polar, Cartesian to cylindrical, Cartesian to spherical, then you need to equate the integral, you need one thing that is known as Jacobian. So here, double integration f of x comma y dx dy, that would be equal to double integration f of r comma theta into Jacobian dr d theta, right? In single variable, like if I'm writing x square dx, only dx, right? So when you are doing here substitution, तो आप क्या करते हो, dx को ही change कर देते थे हम, whatever according to your substitution in dt or in some variable. There is no need to equate it. हम equate यहीं से कर लेते थे, whatever you are getting after differentiating of substitution. But in multiple integral, when you are dealing with the two variable or three variable, when you are equating these integral, you need one thing that is known as Jacobian. So whenever you'll be doing your conversion, Cartesian to parametric even also, then also you need this Jacobian. So now you are converting what? You are converting xy into r theta, Cartesian to polar. So you need Jacobian of Cartesian coordinates with respect to polar coordinates. So you need this. And now you tell me, what is the value of Jacobian when you convert Cartesian coordinates into polar coordinates? What is the value of Jacobian? I asked you remember all these Jacobian when you convert Cartesian. Again, I am telling you to polar coordinates. Value of Jacobian would be r. Please remember it. X, Y, Z. Cylindrical coordinate. Cartesian coordinate would be converted into cylindrical coordinate. R, theta and Z. Again, Jacobian would be r. Remember these two. Tomorrow I'll ask you. When you will be converting Cartesian coordinates into polar coordinates, then value of Jacobian would be r. And if you are converting Cartesian coordinates into cylindrical coordinates, then again value of Jacobian would be r, right? So what you will be doing here, Cartesian को Jacobian में convert किया, r comma theta, Jacobian dr d theta. So value of this Jacobian is r. So when you will be converting this integral xy into r theta, so you will be replacing dx dy with r dr d theta. You will be replacing this dx dy with r dr d theta, right? After that, question would be same. Let us have an example. Evaluate the following integral by changing to polar coordinates, right? So this is your Cartesian coordinates, right? And I need to convert it into polar coordinates. Now you tell me, How to do it? You know that x is equal to r cos theta and y is equal to r sine theta. First of all, you will change this integral into polar coordinates. Then we will talk about the region and limits of r and theta. This is x comma y. So you will be writing here double integration cos x square plus y square would be replaced by what? Yes, Hariya beta, x square plus y square would be replaced by what?
Then r square cos square theta plus r square sin square theta.
And then what? आपने लिख दिया
Ma'am,
r square cos square theta plus r square sin square theta. Niharika, you want to tell me beta? Please, I'll be
Yes,
happy
ma'am.
if anyone is telling me. Yes, बच्चे.
And we'll take r square common and then cos square theta plus sin square theta will be equal to 1.
So
So
I
it will
think it
ultimately
is
be,
r square. Thank you, beta.
yes,
So it
ma'am.
is cos r square and then dy dx. So dy dx will be replaced by r dr d theta. Keep this mind. Whenever you will be changing Cartesian to polar coordinates, so you need to write here r dr d theta. Right? These type of question can be asked in multiple choice beta. Whatever integral can be given, whatever limit can be asked, whatever variable change, what is the effect of change of variable on the integral can be asked, right? So these are smaller things you need to remember, right? So now after this I need what? Limit of r as well as theta. So before that in Cartesian you need to check what will be the region. Now let us discuss it. This is your first question. See, y is equal to under root 4 minus x square. From here, if you will be squaring it, so you'll be getting 4 minus x square. Or I'm saying x square plus y square is equal to 4. What is it? This is the equation of what?
Circle.
Circle
circle.
with center, origin and radius 2, right? So we are making this circle. Why I'm taking semicircle, we will discuss here. This is your circle. Very bad circle. It is your circle, right? See, in this question, vertical strip is given starting from 0 and going up to this curve, right? So y is equal to 0 means x-axis. So your strip is starting from here and ending it here. So that is why this part is not in the region of integration. So now, now my question is whether this quadrant will be included in region of integration or not. So according to this question, vertical strip is given. No? Vertical strip is given that is starting from 0 and ending at this curve. And after that you need to slide it horizontally. So x is starting from 0 and going to 2. Now tell me, should we consider this in the region of integration? Yes or no?
No, ma'am.
Ma'am, no.
No. Why? Because आपका strip यहाँ से शुरू हो रहा था, है ना? ये sliding. This is x is equal to 0 on y axis. Very good, beta. So this is the region of integration only. This highlighted is the region of integration. Now you have converted double integration cos of r square and dx dy would be replaced by r dr d theta. And now you know that this is the region of integration. Now I need the limit of r and theta. For the limit of r, I'll be making a radial strip here. You know that this is the equation of circle, and circle is saying r square plus y square is equal to 4. Or I can say r is equal to 2. So this is the equation, r is equal to 2. Now please tell me what will be the limit of r and what will be the limit of theta. Yes, try it, beta. Limit of r and limit of theta. Only this is the region of integration, this solid region, highlighted region. Tell me the limit of r. For limit of r, your strip is starting here. So what is the limit of r here? Yes, beta, what is the limit at this point?
0.
Yes, 0. Then why are you thinking so much? It is r is equal to 0 and it is going up to what?
2.
R is equal to 2. So this is r is equal to 2. And what about theta?
0 to pi by 2.
Yes, exactly. 0 to pi by 2. So 0 to pi by 2. After that, you need to simplify it. Right? That is your task. So I'll show you this. This is your integral. We have done it. Cos of r square, r dr d theta. Limit is 0 to 2 and 0 to pi by 2. And you will solve it. Right? So that's all for today.